Hey everybody, this is Larry. This is Leetcode Weekly Contest 193. Um, well, okay. Hit the like button, hit the subscribe button. Remember the explanations at the end. Let me know what you feel. And how did you do? Yeah, hope you had a good contest and wish me good luck. Let's get started. And here we go. Uh, Q1. Oh, wait. Recently. So Q1 didn't load, so I went to Q2 first. But I tried going back and forth. I don't know. These beginning of the contest loading has been an issue for me. But this time I just gave up and started on Q2. So Q2, least number of unique integers after K removal. So this one, I read it. I had to read it a couple of times because even though there's a short statement, I was just having issues with reading today, maybe. But yeah, basically when I first saw this, I was like, this is just greedy, right? And I think, to be honest, I was a little bit distracted with the other problems not loading. But yeah, after that, I was just like, let's go. Okay, I read this. I know what I need to do. It's greedy. Let's count them. Well, I didn't know how to write the greedy, to be honest, when I started this, but I knew that I needed to count them first. And I should have used collections.counter, which is a Python thing, but that's besides the point. But yeah, now I'm like, okay, what do I need? Well, I was thinking about making a pairs and then sorting them later or something like that. But I was like, oh, actually, we don't even need the X. We just need the count. So yeah, so then that's what I basically recognized, and then I knew that I needed to sort it. So basically that's, you'll see me start doing that. And then now it's greedy. You have you have to take K of them, so it just remains a while loop that gets the K amount. Basically now we're sorted from the smallest to the largest in terms of counts. So now we try to remove the beginning and then see what's left. And that's essentially what I'm doing here, with some carefulness around the zeros and stuff like that and edge cases. Basically, you take only partial of an array or of a number. That number still exists. So basically that's what I was doing. I knew that when I was running this test, I knew that wasn't complete, but I just wanted to at least see whether it is ballpark correct, so that I could, like if it's really wrong, then I don't have to, I have to do something else. But the good thing in this case is that the example actually has that edge case. I was going to test it anyway because, I don't know, recently I've been more careless and more YOLO, so now I've been trying to go the other way a little bit, where I'm a little bit less YOLO, and in just getting it right. But yeah, so now I did, okay. So if this, basically if K, if we went over K, then we overcompensated and we just put it back in. I ran the test, submit, and that's okay. Okay, I don't submit yet. I actually run more tests. I definitely test a couple of cases on this one, though the server is not as fast as I would like, and also I run into needing premium mode, pay to win maybe? I don't know. Cool. As long as I get the zero case, I'll submit, and then there we go. Cool. And then now we're back to Q1, running sum of 1D array. So this is just what it sounds like. So you blink, you may miss this, but basically you just need to count the running sum. So I just have a running sum, I count it, and then I append it to the answer as I go along. This is pretty quickly, because I don't know. It looks okay, and then I submit it pretty much. So I did this in about 20 seconds. Go Larry. Q3, minimum number of days to make M bouquets. And this one because so I like to do them in order because I don't know, but so that's what I was doing because the problems were loading in the beginning, so I wasn't sure which problem I was looking at. But yeah, now that I settled in, there was just a lot of reading, and that's pretty much what I was doing. I was doing a lot of reading. I didn't understand what this problem was doing. I probably have some bad habits about reading. I go to the example. The example didn't really teach me enough. I go back to the problem statement. I read it again, and I run another example, and so forth. So I did this for about a minute, which if you're submitting in 3 minutes or 4 minutes, that adds up. But as soon as I understand what the problem is actually asking, I go to the binary search pretty quickly. So the idea, and of course, if you're watching, I do go explain these problems at the end. So definitely go to that. There'll be a link below if you like. But fast forward or whatever if you like and go straight to the explanation. But this part, in the commentary part, I do try to explain my thought process as it's happening, which sometimes I don't have the answer right away. Or most of the time even. But yeah, but now I'm just trying to see, okay, boom day. I'm still reading on this problem, on like what's boom day and what's all these things, what are the inputs. And then now I'm like, okay, I think I have the idea. I think I briefly look at constraints, which it's reasonably okay for binary search, and that's the only thing that I checked really. Yeah. And that's pretty much it. So the idea, the explanations will be at the end as well. But so what here is that notice that for a given day, so let's say you're testing a day X, how do you get the most amount of flowers from it or bouquets from it, right? Well, you just do greedy from left to right and construct patches of k consecutive ones as possible. And if you do that, and you look at how many flowers you make, well, that graph of days versus number of flowers or number of bouquets that you can make, it's binary searchable, and you want to find the first instance in which you can make at least 4 bouquets, and that's kind of the problem that we're solving. And again, in the later explanation, I go into it a little bit with some visualization. Let me know what you think about this problem. This was a little bit tricky, I thought, but still pretty cool. But yeah, now I'm just thinking about the edge cases of like, well, not edge cases, but like with binary search, something that, and I have a lot of videos on binary search, is that I get off by 1 errors a lot. So I really think through, okay, what does it mean for each point of the way? That's why I'm a little bit slow, but that's okay, because when I'm fast, I'm wrong, right? And I'd rather be slower and correct than just be wrong, right? So yeah, and this is just the running count, the greedy part of this binary search. Yeah. And as soon as we encounter a day where we can't, we just set to 1 to 0, 0. And if 1 is greater than k, then that means that we made a bouquet. And I just like spaces. And that's pretty much it. Oh, actually there's one more, which is that if it is not possible. I did not handle this case. I was like, and the only thing I caught was that, there's 2 answers in which is a billion. So I was like, oh, it's not possible. So I knew that another way of representing is not possible is if the end of the range is not good enough for this problem. So I did this if statement for that reason, and then that is basically what I did. I was going to just check if your answer is bigger than the max number of days, then return -1. But it could be the max number of days, so that's what I fixed, and then I submit afterwards. With binary search, I'm never super confident, to be honest, because there's always potential for off by 1. So when I click submit, I was just like, fingers crossed. But it seems good. So on to the last one. Kth ancestor of a tree node. So yeah, Q4. This is I don't know what. So a lot of people, when I refreshed, 6 people already got accepted. So well done to those 6 people. I was very this is only 10 minutes into the contest. I was like, wow, is there something I'm missing? Do I, because for me, I don't know if this is a known problem or obscene problem, and leave a comment later below, and I'll explain how I solved this later. But for now, I actually knew when as soon as I saw this problem, I was like, okay, some of this is meta, but it's a Q4 on Leetcode, which I've had practice on. This is it's a quote unquote hard problem, and for a hard problem, you probably can't brute force. And by brute force, I mean an n squared query that goes up, right? Like if each query takes all of n time, that's too slow. So immediately my thought process jumped to finding a log n process, where n is 5 times 10 to the 4th, and that would be fast enough. So I was just thinking about, well, and this is something that actually reminds me a little bit of RMQ algorithm. I was thinking, not specific to that, but that kind of technique where we need to fit something in log n. So instead of storing, in a naive way, maybe you could store the distances as like, okay, for each node, store the first ancestor, the second ancestor, the third ancestor, and so forth, right? And if you have n nodes and you have a degenerate case of essentially a linked list where 1 points to 0, 2 points to 1, and so forth, that's going to be n squared. So those are the things that I'm thinking about. And in this problem, so I knew how to do this problem immediately-ish, but it's the first time I've implemented something like this, so I was really thinking through. And to be honest, I was just thinking, wow, people have solved it really quickly. Is there a stupider way? Is there an easier way? Is there a more obvious way? Or am I doing more work than it's for? I didn't really think, I couldn't find one. So, I mean, that's not to say there isn't, but I couldn't find one during the contest while I was solving this. So yeah, so the idea behind what I later end up doing for this problem is just, instead of storing the first ancestor, the second ancestor, the third ancestor, and so forth, we stored the first ancestor, the second ancestor, the fourth ancestor, the eighth ancestor, and so forth. So basically, we store the powers of 2 ancestors away. And from that, because they're at most log n powers of 2 ancestors, everything will be log n-ish. I do a more in-depth explanation and analysis of this later on in the explanation section. But basically, that's all those things that I talked about are the things that I was thinking about now, and I was just like, and now I'm mostly thinking about the implementation detail, because I haven't done this before, or maybe I've done it before, but I've done it like decades ago. Like maybe the last time I've done this technique was 10 plus years ago, not even exaggerating. And that time I didn't do it in Python. So here what you're seeing is me trying to figure out from scratch, how do I implement this? What is the right approach? How do I get this in a cool, fast way? And this is also what practice would get you, is that you yeah, so basically here I was just thinking about the techniques, and I was like, okay, well, yeah, because I haven't done it in Python before, I was like, okay, I don't know the right way to do it, so let's just, this is something that, as I was saying, if you have practice, then you know how to do it. And on the other problems, I practiced similar things to get the speed that you see. And of course, if you just check out this problem, there's a link to the entire contest below. And I was just like, okay, let's just do everything in a hash table, right? But yeah. But basically, some of this is because I haven't, I don't know, familiar with this part of the Python. So I was trying to think, how do I do basically essentially like a two-dimensional array, but with hash tables, right? So I just wasn't sure about the syntax, and that's also something that if you practice, if you done it before, you'll know how to do without like needing to want to see if it compiles. But yeah, but now I was just basically, okay, let's go through creating the, well, let's start like from what we said. And I'm trying to start from first principles of, okay, well, one distance away or one ancestor away is just a parent, right? And then that's what that's what I put here, though I was, as you can see, struggling a little bit. And yeah, and like I said, I haven't done this in like a decade, so I'm just trying to think about what's the best way to implement this. And you could see that I'm typing very slowly, but yeah. And for this problem, I wasn't sure how far up you may need to go. Wow. So I think I definitely did not implement this looking now. I didn't implement this in the most code efficient way in terms of, you know, just practicing it. But basically, and it turned out to be a little bit of a dynamic programming the way that I did it, but it's very basic dynamic programming, I guess. But basically, the idea is that you know, for each node, what is two distance away? Well, it is one distance away, and then that ancestor one's distance away. So that's the two distance away. How do you get four distance away? Well, it's my grandparent, my grandparents' grandparents, which is another way of saying it's my two distance away, and then kind of doing it that way. That's how I construct. That's pretty much how I construct the list, or construct the lookup. And I don't know why I just one instead, but. And again, the lack of familiarity means that I actually did have, like my base case wasn't quite correct. So yeah, I probably could have just changed the default dictionary, to be honest, but maybe that should be okay. But yeah, now I wanted the one-time issue error. So again, because I have not done this, I am not familiar with it, and some of the syntax is a little bit different. I wasn't sure what is the part that is wrong. And that's why I had to run the code just to see for myself whether my syntaxes kind of make sense. And that's where practice will get you. I know that I talk a lot about practice, and I mean it earnestly. That if you want to be fast, if you want to be good, if you want to be able to solve these, a lot of it is just practice, practice, practice. And of course, you have to learn the fundamentals so that you know what you're learning. It's not just like typing, but you know with that said, if you learn the fundamentals in a good way, even without practice, right? You see me doing this, and I am struggling a little bit, to be honest, but I'm able to solve the problem, right? Maybe I'm not as fast as the people who did it in like 3 to 5 minutes, but like I'm not. No, it's not what you call it either. Right? Like it's not impossible for me, so I'm happy about that. So even though this one I didn't do super well on this problem, I can't complain. I did make a silly mistake that that I think I was just a little bit careless about. I think I thought about it. We'll talk about it when it comes up. And yeah, now I'm just printing out for debugging. I was like, oh, my there are a lot of zeros, so that means that, like I said, I should have just changed the default value to be -1. I think that's what I should have done, but it was just like weird stuff this way. And I spent way too much time debugging this. But some of that is, the learning process and me just thinking about it. Because if you watch me now, and if you're still watching, instead of fast forwarding to the explanation, everything I do here. Okay, maybe not next time. Maybe I still make the same mistake next time with respect to implementation. But eventually I will learn, and I'm excited about that. I'm happy about that. And what you see now and what I'm printing are discovery of how to go about this problem, because I really don't know how to solve, or not don't know, but I have not implemented this before, at least not in 10 years, 10 plus years. So it is definitely something that I'm happy and proud that just with an idea of binary numbers that I could solve this problem. And it also beats just like solving dynamic programming problems the entire time. It seems like that's all the things recently. Yeah. And that's pretty much it for the pre-processing. Now we have to get the ancestor. I was like, okay, that looks reasonably good enough for me to move on. I don't know if it's right, but it's enough for me to move on. And I think some of why I did get a wrong answer is because of my unfamiliarity with this algorithm and how to push it in a way that because I was worrying about space, I was worrying about time. So those were the two things that are on the top of my head. And when you practice these things, you get more confident about certain constraints and stuff like that. In terms of complexity, it should be good enough, but I was worried about space a little bit as well. Though I think looking back, I shouldn't have, because then I could have just handled the edge case in a more cleaner way if I had just done that. But yeah, the idea behind the get cave ancestor, the query, is basically just take the biggest power of 2, remove it, and then keep going. And basically, for example, and I explained this later on, but if you have, say, 15, you take 8, which is the biggest power of 2 that is less than 15, and then you keep. That's what I essentially do, and then you just go move that number of nodes ahead, and because you are at most going to make log k of these jumps once in log k time. Yeah. Cool. Yeah. I went into some errors. I forgot a base case, which is like. Yeah, so this looks good. I was like, okay, what should I test for? I really should have tested for one more case. So I submit, but again, I was really worried about timing out more than anything. Thought that would be fast enough. And log in. And I did actually get a wrong answer, so I was like, huh, okay. I made a critical meta mistake here because I clicked on more details. It didn't tell me any more details. What a ripoff. And the problem now is that I did copy and paste that test case. I did copy the test case, but I don't know what's wrong about it because I didn't get to compare. So I had to take some time to manually create the answer key for this one, which was a waste of a couple of minutes. But yeah, but the short answer is that I did not. There was just an off by something because I didn't go all the way. So it gets stuck on certain nodes because I just keep on recursing on those instead of double checking that if node is -1 because of how I did default dictionary, if it goes to -1, it goes back to 0 because the default value is 0. That is a really stupid thing that I got. I should have just converted the default value to -1 and that would have been okay. But yeah, I just added an if statement and that fixes it. But yeah, that's all I have with this problem. It's like I said, it's the first time I've seen this. Even though I have played around with I know enough about how to do this, so I was able to do it from scratch. Never seen this, never practiced this, so I feel really happy that I was able to solve this. My contest ranking or rating will suffer, but that's okay. The first time you do anything, it's going to be hard to do it really quickly. But yeah, that's all I have. Hang out with the other Larry, and I hope you had a good contest. Okay, I mean, not bad for something that I honestly created by myself. I mean, I don't think I take credit for creating this, and maybe it's a known problem. I don't know if there's a easier solution or not, but it's something that I haven't seen before. But apparently, but it seems like apparently a lot of people have seen this before because, judging by the times, judging by the times, it seems like a lot of people have solved this before. I wish I didn't give away that 5 minutes. That was a really stupid thing not to check, but because I think the thing was that I was just concerned a little bit more about the running time complexity. I was worried about timing out more than correctness. But that was just an edge case that I should have caught. And if I had gotten that, I still wouldn't have been top 100. Maybe there's an obvious reason why. Maybe there's an obvious algorithm, or maybe this algorithm is maybe there's a more naive one that I missed. But either way, well, good job everybody for kicking my butt. But okay, let's take a look at yeah, wow, yeah, a lot of people did really quickly. So there must have been some algorithm that I didn't uh, that I missed. So we'll go over it a little bit later, I suppose. But because I thought there was a because n squared is definitely too slow, but maybe I did something really obvious. Maybe. I'll take a look again now that I could be a little bit more relaxed. How did people do it in like 3 minutes? Maybe it's a known problem, to be honest. So if it's a known problem, then maybe someone just know how to do it. Oh, apparently you could just Google this and no, this is recursive, which is gonna be n squared, and that's the and that's the I don't know. I mean, clearly, it depends on the number of queries there are and stuff like that, but I thought I did pretty fast considering, minus the typo, but okay. Let's just go over the problem right now. I think the thing that I'm a little bit amazed about is how fast everyone done it. Maybe it's a known problem and I'm not that practiced in this well. So yeah, well done everybody, and that means that I am a little bit excited in that that means I get something. I get to learn something, right? So let's take a look. I did have some issues with loading time, because that's amazing that I actually did the Q1 in about 20 seconds or 30 seconds. Too bad I was a little bit slow on Q3 and Q2 a little bit in that regards, but it just didn't load, right? So you saw it on screen. But yeah, okay, let's go over them in order. Q1, running sum of 1D array. So yeah, you just keep track of the running sum, and then you just put it in the array. I don't really know how to describe this problem. You could do it in linear time. It doesn't. These constraints don't really matter because you have to look at each element anyway. So it's linear time, linear space, because that's how much you're returning. This is straightforward, and it is the basis for a lot of different problems in competitive and interviews. So definitely practice this. And apparently I was able to get this in about 20 seconds. Yeah, that's why I have for this problem. That's Q1. Q2, least number of unique integers after k removals. Yeah, so this one, I was a little bit careful while I was doing it because I didn't want to get off by 1 error. So you saw me test a lot. But the idea is that it's greedy. And what happens is that to get the least number of unique integers, we want to remove them from the fewest to the most often. And I did that by putting it in a hash table. I guess I could have used a counter actually in this case. And I sorted by, again, from minimum to max, and then just remove from the beginning until we meet all k. I had to check for the 0 case because of just removal, but otherwise this is O of n space, O of n log n time because I sort, but yeah, for overall an interesting problem-ish. Definitely something that also comes up in other competitive programming problems. By itself, it's okay. As an interview, I guess it's okay. You just have to, I mean, again, it's sorting, it's greedy. Greedy is always a little tricky if you ask me, so I don't know how to tell you about it. You just have to kind of reason it in a good way and intuition and practice and so forth. Yeah, that's Q2. Q3, minimum number of days to make M bouquets. Yeah, so this one is just binary search. So that, which is again based off another thing, which is that it is greedy, and it is greedy by basically given a certain time, you always want to take the earliest running sequence of and make bouquets as much as you can, right? So let's say you have k equals 3 in this case. So let's say you have k equals 3. Like you have this one, then and it's day 7. You always want to make it as soon as possible, because why not? Which is the basis for this greedy. And in this case, we cannot make it on day 7 because the second bunch of it, we made 1, but the second one, well, it goes for 12. So then now as soon as we see 12, meaning that there's a gap, and you might as well treat it as this, then we have to start over, and then we just basically move that along and then creating baguettes as much as possible. And then the question is, well, what is the first day that you can do this? And the first day that it happens is that you can do it with binary search with this greedy, meaning, okay, you test 12. Will 12 give, well, in this case it's 2. Okay, they don't really give you good numbers to show you, but let's say you have this array, right? And you're doing, was it k is equal to 2, and you want to make 4 of them. So yeah, so in this case, you're just trying to, you try 5, and then 5, 5, you cannot make 4 bouquets. Yeah, and then you try a bigger number, and then so forth, such that because it allows you to do greedy, because, well, the greedy part is another part, but the binary search is because the later you get, the more you can always, like, if you add a day to, let's say, on a given day you cannot do it, or if a given day you can do it, the day after that you can always do it, because it's a sort of a subset of, or a superset of before, where you can make more bouquets. You can only make more bouquets as you go on, and from that properly, you're trying to find that line where, okay, I was, on the second day I did 0 bouquet, on the 5th day I did 3 bouquets, and you try to find that line where that meets 4 exactly, and that's basically what I do here. It's binary search, but it's pseudo. The range is on the range of the boom day, which the number of days, which is 10 to the 9th, which is, binary search of that is fine. The only thing that is a little tricky is making sure that you have off by once, which is binary search in general, but also making sure that you handle the -1 case, which I took some time to. Yeah. So the complexity, well, we don't use any extra space really, other than variables. It's all 1 extra space. It's log max of the range of boom day, which is 10 to the 9th. So it's log of 10 to the 9th, which, it's like 40, or it's like 30 or something like that. But yeah, so it's all depending on how you want to say it, because it does not, it's that times n, sorry, so it's n times the log of the max of the range, because for each of these binary search we have log, you could say we have O of log of range of these, let's say log R of these operations, and for each operation we call good, which this is O of n, right? So because we have O of log n of these iterations, each of these do an O of log R, sorry, I don't know what I was saying. So that's times n, which is equal to O of n log R complexity. So yeah, so that's kind of the complexity of this. This is binary search. It comes up all the time in programming, both in in competitive programming and interviews. So definitely practice it. I say dynamic programming because maybe it's just something that's on my mind. But yeah, that's all I have for this problem. That's Q3. Q4. So the way that I did it, I don't know how other people did it, because people did it really fast, almost like people know how to do it already. I did not. I am proud of myself, even though I took about 20 minutes to solve this problem. I actually knew how I wanted to do this immediately, but I don't know how to implement it. So maybe it's that, maybe it's a known problem, maybe people have been practicing. I'm not trying to make excuses, but I'm trying to understand the problem in a way that without seeing how other people did it, I'm just amazed because but some of that may be just that this is the first time I've seen it. And you're gonna have to. Sometimes you have to, solve problems that you haven't seen before, and that's okay. And that's where you hope your knowledge and your practice carries through, and your techniques and what you've learned. Right from here. So the first thing that I think there was just a lot of reading. I wasn't sure what it meant, and then after that, I looked at constraints. Constraints is such that okay, if you have the edge case or the big long case would be like essentially a linked list, right? You have 1 point or 0 pointing to 1, or the other way around, 1 pointing to 0, 2 pointing to 1, so forth. So you have a huge linked list. And if you do something naive, that may easily be n square. So what I did was I knew how to do this immediately in terms of algorithm, but implementation definitely is something that people need to practice on, especially on a language that they may not have done it on. And from here, looking at the n, which is 5 times 10 to the fourth, I knew immediately that I needed something log n, n log n, sorry, where that, or q log n, because if you times q times n, I mean, in this case, n is equal to q, so it's easy to confuse them. But yeah, if you do something that q times n, well, that's going to be way too big, right? It's like 25 times 10 to the 8th, and that's way too big. So we need to get something that, on each query is at most log n. And of course, we cannot do n square processing either. Otherwise, you just do a brute force n square processing, and then for each one, store all the possibilities, which is n square. It takes n square time, takes n square space, which is both of which we don't have. So what I did instead is, I mean, this looks a little bit weird, and it is the first time I've written this, so I am maybe later we'll try to figure out how to practice this. But basically, the thing that I was thinking is, well, like I said, we need log n, right? And here we can do n log n. So what is the way to do n log n? Well, the way to do n log n for me was just to break it down so that instead of, so the naive way would be like, okay, for each node, let's store its parent, its grandparent, its third ancestor, its fourth ancestor, and so forth. So what I did instead was I was thinking about, okay, so the way to do it to save space and time is to store every power of 2 instead. So this is, I forget what the name for this, so sorry if maybe I'll leave in the comments, or if leave in the comments. But basically, we represent all the distance from, so it's, for each node, you store the distance that's 1 away, 2 away, 4 away, 5 away, 4 away, 8 away, 16 away, 32 away, and so forth, powers of 2s, right? So because it's powers of 2, you know that you're going to get log n of them, where n is, at most in this case, is n, which is the size of the input. So that's how I saw create this thing. It turned out that if you thought about it that way, it becomes a little bit of dynamic programming, because I mean, that's the way that I have it kind of written, and I actually didn't think about this as I was writing it, but it becomes dynamic programming because, how do I get, let's say I have a given node and I want to get the fourth ancestor. Well, the fourth ancestor is just my second, my grandparent, which is my second ancestor, and my second ancestor's second ancestor, right? So in a way, you add them together. And how do you get, and then similarly, to get the 8th ancestor, that's just your 4th ancestor's 4th ancestor, right? So that's how I did this loop and this change array to kind of construct that. And then the lookup is just the reverse of that, where I take the biggest power of 2, and then I take the biggest power of 2 to, so basically if like, let's say I've given a random number, like 15, well 15, the biggest power of 2 that's under 15 is 8, right? So then that means we go 8, and then we go 7, and then, we go 8, then we go 4, then we go 2, then we go 1 to add up to 15, and that's basically what this code does. And you could prove that it is log n time because you divide it by 2 effectively at every step, right? So or log k, that is, in this case. So what is the complexity of this algorithm now that we have this algorithm? Well, the pre-processing is going to be n log n because you're given n numbers, and this one's at most log n times because every time you're doubling, right? So it's going to double your distance. Get cave ancestor. This is we get q number of queries of them. So this runs in total q times log k times for the queries. And in space, we didn't have to do this recursively, and if you didn't do recursively, then this is all one space, but I did recursively, so you could have to count the stack space, which is log k, and here, just for the cache, it is n log n because you have n of these first index and you have log n of the second index. Cool. So yeah, so that's all I have for this one. I might check in later, or I might leave a comment about maybe the better way to solve this problem, just because everyone did it in 3 minutes. So it must be, well, not everyone, but like a good amount of people solved this so quickly that that I'm pretty amazed, to be honest. That means that there must be something that, or maybe it's just a known problem. People did it so fast, like 3 minutes. Usually I make up time on the last one, but even if I did this in 3 minutes, I'll be pretty fast. But even if I did it in 5 minutes, I would be barely top 25. And I took 20 minutes plus a 5-minute penalty because that one I was just being careless because I forgot about the edge case. But yeah, that's all I have for this contest. Let me know what you think. Let me know how you did. Hit the like button, hit the subscribe button, and I will see y'all next contest. Bye bye.